Hello, my name is Mark Masters, and I'm the director of the Georgia Water Planning and Policy Center at Albany State University. And over the next few minutes, I'm going to share a little bit about the data and methods used to develop the agricultural water use demand forecast that were put together to support this latest round of statewide water planning. So I'll begin by sharing my screen, and I'll go ahead and turn my video off just to give us plenty of space here. We were joined in this effort by some folks at the University of Georgia, both over in Tifton and up in Athens in the Ag Econ department, particularly Dr. Jeff Mullen and his team, and I'll talk a little bit about his part in this in a few minutes. And we were pleased to help lead this effort on behalf of Georgia EPD and the state to go ahead and put all this data together to support all 10 of the regional water planning councils throughout the state. So this is a team that's been together doing this work since the first round of planning began back in 2009. So I'll spend several minutes here talking about the actual methods that were used to compile this data. And so if we're going to talk about agricultural water demand, the largest use of water for ag is, in fact, for irrigation. And so we began by updating our what we call the wetted acreage database, or the database of known acres in the state that are known to be irrigated for various crops. And so that database was updated to a new 2020 baseline, updated from the 2015 baseline that was put together for the last round of planning. And that update was really a product of a lot of field observations. So my team was out in the field capturing very accurate information on exact acreage, the type of irrigation systems, and all that goes into that in certain parts of the state. And then we supplement that with a thorough review of the latest aerial imagery across Georgia. So we looked at the entire state multiple times, actually, from aerial surveys and satellite imagery, and of course worked closely with the agricultural permitting unit over at Tifton for Georgia EPD. So we've got a really good, updated, quite robust data set of known wetted acreage in the state. And so that was obviously a big component of that. The second piece of that is if you know the acres that are irrigated, it's also quite helpful to know what is being irrigated, because that, obviously plays a role in how much water is being used. Different crops use different amounts of water. And so this is where our partners at the University of Georgia really came into play. We want to try to come alongside the forecast for municipal and industrial uses around the state, and we were forecasting out to 2060, and so to try to align those things and give the councils, is very similar information, if you will. We did a similar thing. So, in order to forecast our use out to 2060, Dr. Mullen and his team worked with multiple different models that USDA puts out. There's a Southeast model, and Dr. Mullen, in fact, has one as well. That looks out into the future with the best available data to say, okay, based on some trends, we think that the pricing of these various commodities that we grow in Georgia are likely to behave in certain ways, and we think that's going to translate into some a particular type of crop mix. And that's really what we rely on to do the forecast. Based on the remote sensing data, and I'll show you some of that in just a second, and the field observations that we get when we're out, mapping and supporting the metering program and things like that, we have a very, very good estimate of current use, because we're measuring it statewide through the metering program, and that really went in to support our model assumptions as well. But the forecast is based on those crop projections, and we'll talk a little bit about that in a minute. So we have our acreage, we have our forecasted crop mix, that is the types of crops we expect to be grown under these acres. And then the third piece of that is something I mentioned before. How much water do we need for those various crops? So we grow a lot of peanuts and cotton and corn in this state, particularly down here in Southwest Georgia where I am. But we also grow pecans, and there's vegetables and pasture and things like that. And all those crops have different water needs. So we've been able to refine our estimates of those needs using the meter data that's been a fantastic addition to our data in Georgia. And then we take that information and we can model the estimated crop demands and thus overall water demands for ag, based on what we think is going to be grown. So we can do that also under different climatic conditions. So our crop water demands in a very, very wet year are much different than those crop demands in a dry year, right? Because agriculture obviously uses more water when it's drier. So we wanted to provide the councils a range of estimated water use based on wet conditions, kind of normal average conditions, but also during droughts. And so that's what we were able to do with these crop models. So known acreage, known for current, and then projected crop acreage, and then we're able to assign water needs based on those crops and based on different climatic conditions. The one thing I want to point out is highlighted here on the screen, and that's the quote 70% assumption. And for folks that were involved in water planning during the first couple of rounds, you'll remember that based on data at that time, looking back into the early 2000s, we didn't have the metering program to the degree we have now. And based on some of those early assumptions, it appeared, and I believe was true, that overall farmers that were applying irrigation water from a surface source were using about 70% less water than farmers using a groundwater source. And that was largely due to the fact that many of those surface water sources were smaller, were on smaller streams, and they just frankly didn't have the water needed to meet the crop demand. And as we have worked across the state and field mapped hundreds of thousands of acres, what we've seen, particularly in Southwest Georgia, is a lot of that acreage that was irrigated with surface water sources is either no longer in production or the source has been switched over. And so what we've seen is a kind of a closure of that gap between acreage irrigated with groundwater and acreage irrigated with surface water. And so in the first two rounds of planning, acreage that was assigned surface water source was assumed to be about 70% less. And so we kind of plugged that in. For this round of water demand forecasting, we have removed that because the meter data, and there are now over 15,000 meters in the state measuring agricultural water use. That metering data tells us that surface water use per acre is pretty well in line with groundwater use per acre. So just keep that in mind if you're involved in this planning work, as you're looking at some of the forecasted demands for your particular council area. Just keep in mind that we have revised that, and we've now kind of done away with that 70% assumption for surface water. And then the final component, certainly irrigation is the vast majority of the water used for agriculture, but animal agriculture and some nursery water use that falls underneath the permitting threshold, we account for that as well. So I'll touch on that just briefly and show you both the 2015, so the last statewide water planning process, and then now the 2020 agricultural water use for animals. And you see that across the 10 different councils plus the metro region. So, they're ranging anywhere from, around 500,000 gallons a day up to a little over 10. And it just kind of depends on where you are in the state, but overall, not huge water demand. Similar story for nursery and greenhouses. You know, ranging again somewhere from around 500,000 gallon a day up to slightly over 10 up in the Savannah, Upper Ogeechee Council region. And so this was provided to the councils as well to kind of augment the information on irrigation. So I'll use the Middle Ocmulgee as just an example of the type of information we gave to the councils. This is a map showing the irrigated areas in their planning council region. This council kind of spans the fall line. So up in the Piedmont, there's almost no irrigation up there, but then you can see down in the southern part of their council region a good bit of irrigated acreage in Peach, Houston, Pulaski counties. You can see the county breakdown there on the right. We provided the councils, you know, a lot of information about, you know, a lot more detailed information about that acreage, exactly how many fields, how many acres, what's the breakdown of source, what's the breakdown of type. We did this for all of the regional water planning councils, and you'll likely see this information in their updated water plans. So how did we go about doing that? Just to kind of close the loop on the methods. What you see now is just an aerial image of kind of what the database looks like. Those circles are center pivots. That's the vast majority of the use in the state. There's 26,000 of those statewide. The irregular areas over on the right-hand side are pecan groves. And so if we look at that, going back to my earlier discussion, we know we have really good information about what's being grown on those areas currently. So this is a remotely sensed image showing that the different colors represent different crops. You know, the crops over on the left on the pivots, you know, you see the one there kind of in the middle that's half green, half yellow. Farmers can split those, right? They may grow half of that field in corn and half in cotton or something like that. So we have really good information on crops. Over on the right, you see all those irregular areas are all the same thing. They're all pecans, and they don't change. So what we can do is, again, using Middle Ocmulgee, we can translate that into an extremely accurate estimate of current crop mix. That will then, of course, that is the baseline that our friends at UGA use to forecast from. But we have a really good understanding of what's being grown currently. So you just see a pie chart of the breakdown. You know, about a third of it is cotton, roughly a quarter is peanuts, and then corn, and then, you know, some other crops broken down as well. So then we assign those polygons, those irrigated areas, water use values based on the crop mix. So remember, you know, some of them change, right? Some of those change from peanuts to corn to cotton. They're split up. And so we developed a mechanism for capturing that sort of dynamic nature of the center pivots. And we assign a percentage across the area. So if the crop mix is peanuts, corn, and cotton, you know, and soybeans, each 25%, we would assign water use values based on that crop breakdown. Obviously, the areas like pecans and pasture, those don't change at all, right? And so for those fields, we have pecan estimates, and those would be assigned to those polygons and stay the same, right, throughout, because those crops aren't changing. And so by doing that and forecasting out into the future, we're able to develop these forecasts. And again, we just use Middle Ocmulgee as an example, and you can see how we develop the groundwater demand as well as the surface water demand. And I've just, you know, shown in this video, you know, that across all three iterations of planning back to 2011, 15, and 20. Just to note, remember that 70% assumption is playing a role here in the surface water. We provided councils, you know, some data to show how their council region compares to their neighbors. So Middle Ocmulgee is there in the middle, and you can kind of see how their demand fits in between Savannah, Berghechi, Suwannee, Altamaha, etc. And then the final thing I would point out, and we touched on it briefly before, agricultural water use is different than municipal industrial. Largely, those water uses remain fairly constant across the year, whereas agriculture certainly does not. We obviously use more during the growing seasons, those spring, summer months, and we use more when it's drier. So we were able to take all of that data and provide the water planning councils estimates of that use over time and over different climatic conditions. So on the screen now is the Middle Ocmulgee's estimates of water use across the growing season, February to November, and then working up the chart, the kind of the darker blue being the 10th percentile. So those climatic conditions I talked about before. In a really wet year, we would expect, for example, the July pumping to be somewhere around, I don't know, 75 or 80 million gallons a day. You would compare that to what we would expect in the Middle Ocmulgee Council region in a very dry July, so a 90th percentile, kind of an extreme drought, where that would be over 250 million gallons a day. And so that helps put in perspective and helps the councils understand that their planning, sort of needs to be nimble with respect to when we have the demand for ag as compared to some of the M&I uses that remain, again, not completely, but certainly compared to ag remain relatively constant throughout the year. So with that, I'll leave my contact information on the screen for just a minute here. We are certainly willing to and would be happy to discuss this with you if you've got any questions about this. Again, all of this material you will find in the Regional Water Planning Council's updated plans that should be coming out in the spring of 2023. And with that, I will stop sharing and turn my video back on just long enough to say thank you for listening, and we're happy to answer questions if you have any. Thank you.